Hello children, today we are going to discuss a new topic, that is polynomials. So in our previous classes we have completed successfully chapter 1 number system. After that, in our class 9 mathematics, the second chapter is polynomials. Polynomials concept is not new for us. From class 7, 8 onwards, we are learning about polynomials. In class 8 also we have polynomials chapter and algebraic expressions we have. In there we have seen expressions, how to factorize, and we have seen many algebraic identities like a plus b whole square, a minus b whole square, a square minus b square. All these are nothing but called algebraic identities. So once again we are going to discuss polynomials in our class 9 with some extent. So whatever we have learned in our previous class, the extension we are going to learn in our class 9, and there is a continuation in our class 10th also. The same chapter polynomials is also there in our class 10. So whatever we are going to learn in our class 9, all these are basics for our class 10. If you are perfect in class 9 the concept, in class 10 it is very easy for us to complete the polynomial chapter. So today we are going to start our new concept, polynomials. In polynomials we come to know the many terminologies. There are few terminologies in our mathematics. In that, when it comes to particular about polynomials, we have a few terminologies. What are they? Here you have some few concepts and few terminologies which are related to the polynomials. The first one is variable. So we are very familiar with variable and constant. The basic in class 7 and 8 what we are learning is nothing but constants and polynomials. Means what is variable, what is constant, that and all we know very well. So we are very familiar with our variables and constants. What is variable? What is variable? The name itself, we have the meaning varying. Varying means changing. What is going to be changed? What is going to be changed? Let me explain with a few examples. X plus 3 is equal to 1. It is one problem. X square minus 9 is equal to 0. It is another problem. X by 2 plus 3 is equal to 5. It is another problem. Now, here we have three different problems. When I solve the first problem, x is equal to 1 minus 3 and x value we are getting minus 2. Here, by solving this problem, x square is equal to 9, x is equal to square root of 9, that is plus or minus 3. Now by solving this problem, x by 2 is equal to 5 minus 3, x by 2 is equal to 2, x is equal to 4. When we observe these three problems, in all the three cases we are using the unknown value, means the variable. Here what is the unknown value we have? X. X is an English alphabet and x is unknown value in each problem, In first case, the value of x is minus 2. In the second case, the value of x we have plus or minus 3. In third case, the value of x is nothing but plus 4. In three different cases, I have different values for x. Means, here the value of x is not fixed. According to the situation or according to the problem, the value of x is changing. Changing in the sense, varying. The value of x is varying. So, here the unknown value x is nothing but called variable. The value of x is nothing but called what? Variable. So, in this case, the value of x is minus 2. When it comes to the second problem, the x value is varying from minus 2 to plus or minus 3. Means it has changed. Now when we come to the third problem, again the value of x has changed from plus or minus 3 to plus 4. Here the value is minus 2, here the value is plus or minus 3, and here the value is 4. In every case, the value of x is keep on changing. Changing in the sense, varying. So, what is the definition of variable in the sense? For what values? For what values? Or for what English alphabets? We don't have fixed values. We don't have fixed values. They are nothing but called variables. Usually, the variables always will represent lowercase alphabet, means like small x, small y, small z, like that. With these lowercase alphabet, we use it to represent the variables. For these values, we don't have a fixed value. For these values, we don't have a fixed value. These are nothing but called variable, means where we don't have a fixed value, we don't have a fixed quantity. That is nothing but called variable. So, the first one is completed. Next, another one is constant. Reverse. Variable means where we don't have a fixed quantity. Constant means where we have a fixed quantity. Constant. Constant is always constant. It never change. It never change. For example, if I go and ask, now our concept is what? Constant. What is constant here? Constant. Constant is nothing but a fixed quantity. A fixed quantity, or we can say without varying, without changing. There is no chance to change the value. Whatever it may be the situation, the value has to be fixed everywhere. For example, when I go and ask class 11, what is the value of x? We don't know. If I go and ask in class 10, what is the value of x? We too don't know. So, as I told you, the value of x depends on the situation. Value of x depends on the situation. Earlier we have seen three problems. If I give the first problem for class 11, we get minus 2. If I give the second problem for class 10, plus or minus 3. If I give the another problem for class 9, you will get 4. Means everywhere we are getting x value. When I ask class 11, x is equal to minus 2. When I ask class 10, x is equal to plus or minus 3. When I ask class 9, x is equal to 4. Everywhere the value of x only. But the value of x is changing. If I want to ask class 9 student, what is this value? Undoubtedly they will tell the value 5. Same question, if I go and ask for class 10, they also will give the same answer. If I go and ask for class 11, they also will give the same answer. So, when I have given this value, I am getting same result from everywhere. Means it has a fixed value. It is a universal fact. Wherever you go, whoever you ask what is the value of this means, everyone will say that 5. Means it has a fixed value. These are nothing but called constants. These are nothing but called constants. Constants are nothing but, so which is having a fixed quantity, which is having a fixed quantity or without changing. That is nothing but constant. Constants comes under almost numbers. All our numbers are nothing but considered as constants. In general case, in our polynomial concepts, usually the constants we represent with small a, small b, small c, small d, etc. These are we are using for constants. So a, b, c, d and so on. All these lowercase alphabet represents constants. As I told you previously, x, y, z. These are represents variables. So you no need to confuse anything. Wherever you have x, y, z, all these alphabet represents variables. All these alphabet represent constants. So constant means we have a fixed quantity. Variable means we don't have a fixed quantity. That is about constant. Next, the another term what we have is term. The another one, term. So what is the meaning of term? What is the meaning of a term? So just now we had a discussion about variables and constants. Just now we had a discussion about variables and constants. Now we have a concept of term. In English language, we have alphabet and we have words and we have sentences. Next we have paragraphs. Next we have lesson. How we are getting the first? Basically we learn English alphabet A, B, C, D, E, like that we learn. Later what we do? By combining or the combination of alphabet, we frame it words. Bed, B-E-D. B is a letter, E is a letter, D is a letter. The group of letters we have a word. The group of words we have a sentence. The group of sentences makes a paragraph. Like that. The group of variables and constants. The group of variables and constants gives us a term. For example, the definition of a term is nothing but a constant or a variable or combination of variables and constants. So this is the definition of a term. So what is given term means? Term may be a constant, may be a variable, may be a combination of constants and variables. For example, x, it is a variable and I can also call it as a term. 5 is a constant, I can also call it as a term. 5x, it is a combination of constant and variable. 5x, 5 is a constant, x is a variable, and the combination we are taking as 5x. The meaning of 5x is 5 into x. So 5x, it is also a term. 5 by x. 5 by x. Again here we have a combination. 5 by x. It is also a combination. Combination means we have to use the operations multiplication and division, not addition and subtraction. Here I told you that the combination of variables are constant. Combination means we are going to use the operations only multiplication and division. Here we are using which operation? Multiplication. Here what is the operation we are using? Division. So these two are comes as a term. If I ask that 5 plus x, it is not a term. Which is not a term. So we should use only the operations multiplication and division. Next, x by 5. It is also a term. X into y. It is also a term. X square y, which is also a term. 1 by x, it is also a term. X into y into z, which is also a term, etc. All these are nothing but examples for a term. Here we have a variable, constant, combination of constant and variable, constant and variable, variable and constant, combination of variables, combination of variables, constant and variable, combination of variables. All these are examples for a term. Next we have algebraic expression. Our next concept is algebraic expression. So what is the meaning of algebraic expression? Algebraic expression. As I told you, in English language, the group of alphabet makes a word. The group of words make a sentence. The group of sentences make a paragraph. Similarly, term is nothing but what? A constant or a variable or the combination of constants and variables. Now, algebraic expression is nothing but the combination of terms. The combination of terms is nothing but called algebraic expression. So, how to combine? How to? Here combination means combining. How to combine? So, in mathematics, we have four fundamental operations. What are they? Addition, subtraction, multiplication and division. For term, we are using multiplication and division operations. For algebraic expression, we are going to use addition and subtraction operations. So, by using the operations addition and subtraction, we are going to combine the terms. We are going to combine the terms. So, algebraic expression is nothing but the combination of terms by using plus or minus, by using plus or minus is called an algebraic expression. Is called an algebraic expression. So what we are doing here in the sense, we are going to combine the terms. So by combining the terms, by using the symbols of addition and subtraction, we have a new form that is nothing but called algebraic expression. For example, x is a term, 5 is a term. Now these two terms I am going to combine with plus. Now what I have? X plus 5, which is a term, which is an algebraic expression. X square minus 3 is an algebraic expression. X cube plus 3x square minus 5 is also an algebraic expression. 2 into root x plus 3 by root x is also an algebraic expression. 3 into x to the power of minus 2 plus 5x minus 1 is also an algebraic expression. Now, I have given different examples. X is a term, 5 is a term. The combination of terms we have an expression. X square is a term, 3 is a term. The combination of these two terms we have an algebraic expression. X cube is a term, 3x square is a term, 5 is a term. The combination of these three terms we have an algebraic expression. 2 into root x plus 3 by root x. Here 2 into root x is a term, 3 by root x is also a term. The combination of terms we have an algebraic expression. 3 into x to the power of minus 2, 5 into x minus 1. Here also 3x to the power of minus 2 is an algebra, a term, 5x is a term, 1 is also a term. The combination of these three terms we have an algebraic expression. So all these comes under an algebraic expression. The combination of terms by using either addition or subtraction or both is nothing but called an algebraic expression. This is also completed. Next concept we have polynomial. Next concept we have polynomial. So, what is the meaning of a polynomial? What is the meaning of a polynomial? So, now I am going to list out a few examples. With that examples, you can come to know that what is an algebraic expression and what is a polynomial, and what is the difference between algebraic expression and what is the difference between a polynomial. You can have very clarity, and moreover you can understand the concept of polynomial also. Let me explain it. For example, here 3x square plus 7x plus 5. 3 by x square plus 7 by x plus 5. X plus 7. 1 by x plus 7. X cube plus 3x square minus 5x minus 1. X power minus 3 plus 3x square minus x to the power of minus 1 plus 7. X power 5 x to the power of minus 1. Now, here we have total 4 examples. Here 4 and here 4 examples we have. Basically, all these are nothing but algebraic expression. No doubt at all, because 3x square is a term, 7x is a term, 5 is a term, x is a term, 7 is a term, x cube is a term, 3x square is a term, 5x is a term, 9 is a term. 1, 2, 3. These three terms we are combining by using addition, so that we can call it as algebraic expression. X, 7. These are also two terms we are combining with the addition. 1, 2, 3, 4. 4 terms. By using addition and subtraction, we are going to combine. So here also 3 by x square is a term, 7 by x is also a term, 5 is also a term. All these are we are combining with plus, so that we can call it as an algebraic expression. 1 by x plus 7, it is also an algebraic expression. X to the power of minus 3 plus 3 into x square minus x to the power of minus 1 plus 7. It is also an algebraic expression. And here x to the power of minus 5, it is also an expression. All these are nothing but an algebraic expression. Undoubtedly, all these are algebraic expressions. Now, what is polynomial? What is polynomial? Now, just observe these 4 examples. Now, you might have understand why I have written here a 4 separately and there another 4 separately. Once if you observe these two, this column and this column, definitely you can notice some difference. What is the difference? Here we have the unknown value x, and what are the powers of x? Here x is having the power 2, here x is having the power 1, here 5 is nothing but what? Constant. Constant means we don't have a variable. Of course there is no variable, we can write it as x power 0. Now you observe here x is a variable and the powers of x 0, 1, 2. How the powers of variable we have? 0, 1, 2. What are 0, 1, 2? So I can call 0, 1, 2, 3 and so on are nothing but whole numbers and also called non-negative integers. Non-negative integer means which are not negative. Which are not negative in the sense 0, 1, 2, 3, 4, 5, 6 and so on. All these are nothing but called non-negative integers are nothing but whole numbers. So in this example, the powers of the variable are non-negative integers means 0, 1, 2. Now come to the second example. Here x is the variable having the power 1. 7 is a constant. We can write it as x power 0. So here also when we observe the powers of variable, here I have the variable power is 0 and here I have the variable power is 1. Again non-negative integers. Now coming to here, 3 is the power, 2 is the power, x power 1, x power 0. 0, 1, 2, 3. Here also we have non-negative integers. Non-negative integers. X power 5, which is also non-negative integer. In all these 4 examples, the variable powers are non-negative integer. The variable powers are nothing but what? Non-negative integers. Coming to here, 3 by x square. 3 by x square, which means 3 into x to the power of minus 2. What is the power we have? Minus 2. 7 by x. 7 into x to the power of minus 1. What is the variable power here? Minus 1. 1 by x means x to the power of minus 1. Here also the variable power is minus 1. Here the variable power is minus 3, minus 1, minus 1. In all these 4 examples, we have the variable powers are integers. These are only integers, means you have negative integers also. What we have? Negative integers. In all these 4 examples, we have the variable powers are non-negative integers. Whereas in these 4 examples, the variable powers are integers. Means you have some positive integers, you have some negative integers, and you have also 0. Non-negative integers. So where you have the variable powers are non-negative integers, these algebraic expressions are nothing but called polynomials. So all these are nothing but called polynomials. All these are nothing but called algebraic expressions. So basically all these are algebraic expressions. In that again we are bifurcating with some property. What is the property? in an algebraic expression where the variable powers are non-negative integers are nothing but called polynomials, and where we have the negative integers and positive integers and 0 means finally integers as the variable powers are nothing but called algebraic expressions. These are polynomials, these are algebraic expressions. Now I can say one thing. Basically all these are algebraic. Basically you are a student. Basically you are a student. After that it comes which class you are belongs to. Which class you are belongs to. So when you are a student, then I can ask you which class you are studying, whether you are studying 9th class or 10th class or 11th class. If you are not a student, so there is no meaning of asking which class you are studying. I hope I am very clear. For example, when just we are roaming on a road, if I saw a child, so casually when we have a talk with that boy or girl, what you are you a student or not? If that boy or girl says, yes, I am a student, yes, I am studying, then I can ask which class you are studying. If he or she says that, no, I am not a student, then can I ask a question, which class you are studying? If I ask that question, definitely that boy or girl will say from bottom to top, are you a man? So, basically all these are algebraic expressions. Once if it is an algebraic expression, then it comes polynomial. How the polynomial means? Depending on the variable powers. So, all polynomials are algebraic expression, but all algebraic expressions are not polynomials. This is the concept about polynomials. Now I give the definition of polynomial. The definition of polynomial is polynomial is an algebraic expression whose variable powers are non-negative integers. Whose variable powers are non-negative integers. So, polynomial is nothing but an algebraic expression in that whose variable powers are non-negative integers. This is nothing but the definition of polynomial. So, all polynomials are nothing but algebraic expression. All algebraic expressions are need not to be polynomials. So, polynomials and in one variable. Now we have seen all in one variable only. What is there? For example, 5x cubed minus 7x square plus 7x minus 3. It is a polynomial in one variable because everywhere we have the variable x. So it is a polynomial in one variable. So that is about polynomial in one variable. Next concept, zero polynomial. What is the meaning of zero polynomial? Zero polynomial. Zero polynomial is nothing but a constant polynomial whose value is 0. Zero polynomial is nothing but a constant polynomial. Means, as you know that constants. Here 5 if I take, which is a constant and it is also a constant polynomial. if I take minus 7, which is a constant and is also a constant polynomial, like that, when we have 0 is nothing but called 0 polynomial. You can call it as a 0 polynomial. Next we have monomial. Mono means 1. Mono means 1. So what is the meaning of monomial? What is the meaning of monomial? Monomial means in which polynomial? Polynomial means what? Combination of terms. If a polynomial contains only one term, is nothing but called monomial. For example, 5x. Basically it is a polynomial and this polynomial contains only one term. So we can call it as a monomial. Minus 7x square is also a monomial. Minus 10 is also a monomial. X power 100 is also a monomial. Means only one term, and only one term. All these are nothing but called monomials. So monomial is nothing but in a polynomial, if you have only one term, is nothing but called monomial. So how many terms has to be in a polynomial? Only one term. If a polynomial contains only one term, that is nothing but called monomial. Next, now you may have a doubt, sir. Earlier we discussed about a term. Now we are discussing about a monomial. So what is the difference between a term and a monomial? Definitely you will have a doubt. Just now I gave an example. 5x is a monomial. Minus 7x square is also a monomial, I said. Minus 10 is also monomial, I said. Next, x power 100 is also monomial, I said. Now you may ask that these are nothing but terms only, no sir? Definitely. All these are terms only. Now, what is the difference between term and monomial? What is the difference between term and monomial? As I told you, in term we are using both addition, multiplication and division operation. But here I am not using any division operations. Here all I am using multiplication operations. And moreover, if I say that x by 5, now what is this x by 5? Now can I call it as a term? Can I call it as a monomial? What I can call it is, I can call it as a term and I can call it as a monomial also. I can call it as a term and I also call it as a monomial. But whereas if I have 5 by x, I can call it as only a term, but I can't call it as a monomial. So, which is not a monomial, it is only a term. That is the difference between monomial and term. Next, binomial. Next concept what we have? Binomial. So monomial is completed. Next concept we have binomial. Now what is the meaning of binomial? Bi means 2. Binomial is nothing but what? 2. So earlier mono means only 1. Now binomial means 2. Means in which polynomial we have two terms. A polynomial with two terms is called binomial. The definition of binomial is nothing but what? A polynomial with two terms is called a binomial. For example, x plus 5, x square minus 3, x by 5 minus 7, x power 100 minus x. All these are nothing called binomial because here I have two terms, here also I have two terms, here also I have two terms, and here also I have two terms. All these are nothing but called binomials. So a polynomial with one term is called monomial. A polynomial with two terms is called binomial. Next, another one is trinomial. Tri is nothing but 3. A polynomial with 3 terms is called trinomial. Monomial, mono means 1, bi 2, tri 3. Polynomial with one term is called monomial. Polynomial with two terms is called binomial. Polynomial with 3 terms is called trinomial. Now you may have a doubt. More than 3 terms, sir? More than 3 terms is nothing but called multinomial. Polynomial with one term is called monomial. Polynomial with 2 terms is called binomial. Polynomial with 3 terms is called trinomial. Polynomial with more than 3 terms is called multinomial. So these are the basic terminologies which we need to discuss in our polynomials chapter, and we have elaborate discussion with examples also. In our next class, so we discuss about what is a degree of a term, what is the degree of a polynomial. Based on degrees, what are the types of polynomials we have, and zero of a polynomial. All those concepts we discuss in our next class. Hari Om.